Welcome back. Today we're going to look at how to solve a capital budgeting problem using time value of money concepts. And there's several different methods, and the three we're going to use here are payback, net present value, and internal rate of return. So what I've done is I've made a timeline down here, and I've got an investment we're going to make, let's say, in a piece of machinery, and it cost us $25,000 today for the machine, and then we're going to realize returns in each of the next 5 years, reflected down here. And our cost of capital is 7%. So what I've done is I've taken these numbers and put them in a nice table here, and what we want to do first is to calculate the payback period. So let me put a label up here. Okay, just widen that out so you can see the whole thing. So what you do when you calculate a payback is you made a $25,000 payment here to buy this piece of machinery, and you want to know how long it's going to take you to get it back. So you start out with $25,000, and then in the first year you've paid, or you've gotten back $8,000 on that 25. So let's put that in our spreadsheet. And at the end of the first year, we have $17,000 left to recover. So let's do the next one. Year 2, we're gonna, from the 17,000, we're gonna get another 10,500. Now notice we only need $6,500 more to recover our $25,000, and in the next year we're going to get $13,000 down here. So what that means is a half year into next year we should be pretty much recovered. So let's throw the $6,500 in here. That's what we need, and we know we're going to get 13,000. So that's how we get a half a year. So we have year 1, year 2, and a half a year. So our payback period is 2.5 years. Everybody see how I did that? Okay. So payback is a pretty quick and dirty measure, and it's pretty unsophisticated. And the problem with the payback period is it ignores the time value of money. We did nothing with time value of money. The other thing bad about it is it ignores any cash flows after the payback period. So it ignored from the second $6,500 in year 3 all the way down to year 5. So that's bad, because those could be very good cash flows, and actually they are here. So probably it would look a lot better if those things were considered. Not that it's bad, it's just, it'd be that much better. So let's look at another method, which is called the NPV, or net present value method. And what this method does is it calculates the present value of the returns and subtracts the initial investment. So there's 3 ways we could actually do this here, and the first way is to use our Excel financial function. So if we open this up, and let me put it a little closer here so you can follow along with me, and if we go to most recently used, here's present value. So that's what we're going to use here. And we have a cost of capital of 7%. We'll use that as our discount rate. Okay, so 7%, we put that in. Our number of periods here is 0. So let's put in 0. We put nothing in payment, and what we're going to pay out now is minus 25,000. That's going out the door. Okay, so we've got 25,000, and it actually changes the sign anytime. If you put a negative in, it comes out a positive. So it always changes the side. So if we want to see it as a negative, to show that it's going out the door, we have to delete the sign, and then it'll put the 25,000 in our result. And we can click OK, and there's a minus 25,000. Okay, that's our initial investment, and it's worth what it is today. So so that's 25,000 that we just lost. Okay, so let's go down to year 1, and we're going to do the same thing. We're going to calculate our present value. We'll open our box here, and our rate is 7%. And we're now at the end of year 1, so we'll put the cell address in, and it shows number 1 over here. And then our future value, or the amount that we're going to get back at the end of year 1, is $8,000. And this time we have to change the sign again because we want to know what it's worth now instead of in the future. So present value, we're always going backwards, so it's the opposite. So that's going to give us 74, 76, 64. And there it is. Let's do the next one for year 2. So we open year 2, present value. We put in a rate of 0.07. We put in our period here, which is period 2. It shows over here. We put in a minus, and then we put in our cash flow at the end of year 2. It gives us 9171.11. So we can put that in. And because we've been putting the cells in, why don't we just copy this for the next 3 years? Because it's automatically going to pick up the right year, and it's automatically going to pick up the right cash flow. So if we paste that in here, those are our cash flows. Now all we have to do is take a total, and we can come over here to auto sum and select sum, and it gives us 24,248.11. So that's our net present value. You know what net present value means, again, is the sum of the returns less the initial investment, discounted back to what they're worth today. And that's what we did here. Let's look at doing it another way. We're going to do it now using the Excel, or we're going to use the formulas like you would see in a finance text. So what we want to do here is we want to take our $25,000, and we're going to multiply the $25,000 times our discount rate. And our discount rate, and we got to put in parens because we have a hierarchy of operations problem here. And so we have it's 1 divided by 1.07. That's our discount rate. And we raise that I must be hitting something wrong here. Okay, we got to fix this. We got to raise that to the 0 power, and the 0 power simply means 1, so that's what it's worth today. So if we hit enter, there's our $25,000. Okay, so let's do the next one, and then we'll copy. So we'll do one more here. So we'll put in an equal sign, and we're going to put in our cash flow of 8,000, and then we're going to multiply that. So we have to put in an asterisk, and we're going to take that times our present value factor, which is 1 divided by 1.07, and that's going to be raised to the first power. So we'll just grab it from over here, and we got to close our parentheses, and we hit enter. And there it is. We got the exact same thing we did with the function. So we're going to copy this down to the balance of the periods. And everything is the same. We can total it up again using the AutoSum. And there you have it. Okay, so we did it two ways, and those ways are fairly easy, but there's an even better way, and I'll show you the better way. This time we're going to use a function called net present value to calculate net present value. And what we need to do here is, before I do this, we need to put in our equal sign, and then the first thing we're going to do is subtract or take the negative 25,000. That's our initial investment. And then we're going to do our net present value. So we have to come back up and open up net present value. Click OK. Our rate again is 0.07. And then if we click in value 1, we take everything except the initial value and click OK. We get 49,248 for all of these. And then if we subtract out the 25,000, it gives us 24,248. So we came up with the same thing, just in another way. So we'll put our label in there, and we can copy this and paste this over here. So that's how you calculate net present value. So anytime you have a positive net present value, that means the cash flows are sufficient to accept the project. So in this case, you'd want to accept this because the end result is going to yield $24,248, which is good. Okay, now we're going to show you the third way to evaluate a project, and the third way is called internal rate of return, or IRR. Okay, so we're going to use IRR, and while IRR is probably the most difficult to understand, it's the easiest to calculate using Excel, and I'll show you real quickly how simple it is. Okay, we're going to find IRR in our table, click OK, and all we have to do is come back over to here, highlight all these numbers, and put them in values, and you see them there. Our internal rate of return is 34.21%. So should we accept this? Yes, because when our internal rate of return exceeds our cost of capital, that means it's a good project. Okay, so we've done it three different ways here, and you probably wonder which is the best way. If you had a business and you wanted to evaluate projects, which one would be the best one to use? Theoretically, NPV is the best approach because it considers the outside world's cost of capital, or the opportunity cost of capital. In other words, what it takes to raise funds on the outside. Whereas internal rate of return, although it's a good measure, and a lot of firms use it because it's easier, like I just showed you, it sometimes does vary, because if the cash flows turn negative at some point, you can't use it. That's one thing. And sometimes there are some points where it's not the same as the net present value. You'll actually get a different result. And it only considers the internal rate of return and not the external rate of return, or what you could get on an investment outside your own firm. So theoretically, NPV is the best one to use. Okay, so that's it on time value of money to evaluate capital projects, and we'll see you in the next slide.